Thanks very much for that introduction. Just get this running here.
Working on 6 Greg.
All right. I don't know how many of you people have read the Control Surveys and SCIMS document, SG12, but I suppose any of you that have, had work that may have required submissions to get data into SCIMS as part of your contract requirements, you'll probably know a little bit about this document and some of the background behind it. I don't remember the exact date that we released the document, but it was last year after sending it back and forth to the public and yourselves for amount of time. But I'll talk a little bit about that, why we actually created it, a little bit about standards and specifications, and things to do and things not to do. Now, most people have standards. They're standards for making classifications for general movies or anything that's shown on television, and that's basically based on social standards. Now, look, I don't really go into a lot of cadastral stuff, but just talking about standards, that Ordinance 70 there says building not less than 900 millimetres or 2 stories or 1500 millimetres in the case of a building containing 2 or more stories. Is 890 metres okay? Millimetres okay? Or in what context is that document written? Do you say, oh yeah, look, 30 millimetres, it's close enough? Right, so I think things like this are a little bit, are they black and white? The survey regulation now has been changed to 5 millimetres plus 25 parts per million. That's at a confidence interval of 67%. All the stuff that I'm going to talk about in this document, I prefer to use 67% because that actually defines how good you've got to measure. Right, to achieve a 95% result, you've got to be able to demonstrate this. Now, before, in the old regulation, that's an example of a pocket tape that you needed to do your work, because the bottom line was 10 millimetres. So there was no reason to have millimetres on a pocket tape if that's the best you had to measure. That's what the new document looks like when you get it off the website, which is at the top of that slide there. From time to time, our IT people get ideas about how our web page should look, and these things do get moved around a bit, and where it was last time might necessarily be where it is now. Anyway, why we created SG12. Now I've added this in since anyone who saw the last time this presentation was done. What's behind a coordinate of height? Now, this is basically what happens in our organisation. There's that's the village of Newbridge. Okay. There's all the SCIMS marks that we've put in there. You'll notice, I hope you can read that slide, it's a bit cluttered, but there's cadastral reference marks we've coordinated, there's PMs and SSMs, and that's been a recent job done for cadastral upgrade. Let's look at that PM there, 179651. This is being displayed in our ARC GIS system we have at LPI. I'm looking at, as I said, now that PM is in source ID 234787. Now that's our traceable number back to the origin of the coordinates for that mark. Okay? This is the sort of thing that we have to support our public data set, the SCIMS data set. Okay, this is, you'll see there, adjustments and project data. Down here, these are the source IDs. You can see there it starts at, let's say the continual run numbers would probably start at about 22,700, so 227,000, right? And we're down now to 235,000. This is source IDs that we keep track of, right? And you can also see that this is historical as well, so we can backtrack through old source IDs. Okay, so then we know that the Newbridge number was 234787, I think. There we go, 234787, Newbridge DCDB upgrade. Now in that directory there we've got adjustments, log sheets, pictures, processed, raw data, reports, senior surveyors, comments, and a shapefile. So if I look in the adjustment directory, we've got our adjustment files. That's a record of the source of these, of the coordinate for that PM. So in that adjustment file, there'd be that PM. And we go into log sheets. All our data that was captured in the field, it's been scanned and put into PDF documents. There's one page out of that PDF document. Now, it's not a good example. The date's missing off that document, but there is a day of the year there. Okay, and it's RTK rover, and it says what the base station is and all the observed points. Then we've got our raw data archive. I've jumped over, there's pictures, there may be photographs there of particular marks that are thought appropriate. And there's also processing that may have been done, GPS processing, some records of that there. We've got raw data, there's RTK raw data, there's static raw data, and there's Travis raw data that's been collected with a total station. Then we go to reports. Okay, we've got newbridge.doc. Here's a copy of that report done by one of our, see if I can get this a bit better here. View, full screen. How's that? Can you see that? Okay, well, this is young Lisa Powell, one of our technical surveyors we've got at work. This is her. This report that's here is, there's a sample of this structure on our website associated with the SG12 directions. But you can see it's quite comprehensive. She's taken photographs of, there's a cadastral reference mark there that they're RTKing. Things like observation variances she used in the adjustment, information about the adjustment that was done, and any comments about things. Here we go, we've got quality of some of the marking that we've found. You can see that concrete collar around that mark's been a bit inadequate. We've got another picture there showing a PM and an SSM less than 5 metres apart. The results of the adjustment, more comments, some of the network geometry. She's done that in there's blow-ups of various bits and pieces there because the whole thing won't fit on the thing. And then there's the senior surveyor's comments, and then we've got an appendix of listed coordinates, cadastral reference mark numbers and allocations, right? So this is all in support of that. You'll find that 1 PM will be in this job. So I'll put that up just as a, just to give you some idea of, you know, when we receive data that's related to SCIMS, like this is what our standard is internally, and we'd like to think that we could get something that was even halfway to that would be good. Okay, and we've got senior surveyor's comments, and then he's done some readjustments just to check some things. Then we have a shape file. In there, we're able to put up what that network looked like. Okay, so that was just a background in what our process is at LPI in support of the SCIMS database. Okay, well, now I'll start talking a bit about standards and so forth. Class, Doug did put this up before, but that's the definition as defined in SP1 and the Surveyor General's Direction number 12. It's identical. That little formula there is very common, and it's currently the accepted formula for the determination of both class and order, both horizontally and in some cases vertically. These are the class values for various types of surveys, and we're particularly interested there in Class C, which is a value of 30. So for 1 kilometre, where D equals 1 kilometre, the allowable errors of the relative error ellipse is 30 millimetres. Now, when you do your survey, you control the class of the survey, and the survey is datum independent. And there's other in control surveys. You also have a determination of order, and there's things like uncertainty. We haven't implemented uncertainty as we would have wished, but we do have some problems. But with positioning, uncertainty becomes a valid classification system in some cases. If you look in SP1, there's processes to define, and there's a list of tables that I've taken out of SP1 that just defines the methodologies required to do certain types of surveys. Mark placement. It's another thing about control surveys is, is the mark what's the stability of the mark like? Is it placed in safe locations, public accessibility? Locality sketch plan is an important one. Like, show connections to physical features so that we can find the mark. You'll find that a number of sketch plans that you do recover from the sketch plan system are photocopies of parts of cadastral plans. Now, they don't represent what's physically on the ground out there. So they're very they're not very useful for recovering marks. There's a couple of poor marks, samples of poor marks, an SSM right on the edge of a freeway, and a cover box that's obviously been lifted up with cement to get it over the top of the pin. Know what your equipment can do. Class C requires about 30 parts per million. You can do that with a 5-second instrument. You can have an EDM that measures 5 millimetres to 5 parts per million. Now, you can do Class B with that instrument if you know the limits. The important point there is be aware as distances shorten, achieving a desired class becomes more difficult, as Doug showed in his slide. Be aware of things like network design and geometry. Don't jump over adjacent marks just because they are inconvenient with the equipment that you're using. This only leads to problems in the future. Always interpolate results, don't extrapolate. Network design. There's a couple of networks there. I think the one on the left is out at Peel. Now these are combinations of GPS, RTK, traversing, and information off cadastral plans. We accept that, okay, the regulation was 10 millimetres plus 15 parts per million for measurement. There's a limitation on that, but we do use that in conjunction with our own measurements and accept Class C for that, and third order coordinates. The one on the right there is Broken Hill, which was done with RTK and cadastral plans. All the blue lines on there are